Unit 10, Day 7, Solving Exponential Equations, continued. So, review number 1. Previously, in Unit 9, we learned how to solve a problem like this via graphing, but now we've learned how to solve it via taking a log, in this case a natural log, of each side. So let's do that. That means that ln of e to the x equals ln of 55. ln of e to the x is x, so x equals ln of 55. We can grab our calculator. We will put in log, natural log of 55. 4.007, or about 4.01. State the domain of y equals log 4 minus x. Well, you can't take a log of a negative number. No positive number raised to a power is going to be negative. So instead, what we recognize is that inside of the parentheses, this must be a positive number, therefore x must be less than 4. Give an exact solution to the following equation. 62 plus 2 times 8 to the x equals 14 plus 3 times 8 to the x. First, we're going to apply our order of operations, PEMDAS. There are no parentheses. The exponent goes with 8 to the x. That's fine. Multiplication, 2 times. So this is 2, 8 to the x. And this is 3, 8 to the x. So we're going to hold on to those separately. And then we have division. We don't have any of that. Addition and subtraction. Well, we do have addition. So let's subtract 14 from each side. I'll write over here. 62 plus 2 times 8 to the x equals 14 plus 3 times 8 to the x. We're going to subtract 14 from each side. And I'm going to subtract 2 times 8 to the x from each side. So 62 minus 14 is 48. 2 times 8 to the x minus, 3 times 8 to the x minus 2 times 8 to the x is 1 times 8 to the x, or just 8 to the x. So, last chapter we learned change of base. If b to the x equals a, then x equals log base b of a. In this example, here's our x, here's our b, there's our a. In our problem that we have, here's our b, there's our x, and there's our a. So we're going to rewrite this. X equals log base 8 of 48. Now to do this, we don't have a log base 8 in our calculator, so we have to use our change of base formula, which says that log base b of x equals log base a of x divided by log base a of b. Here's the weird part. This b is now 8. This x is our 48. And our log, well, in our calculator, what we know is we have either ln, natural log, or log, which is just base 10. So we're going to use log base 10, because that's what we have in our calculator. So, log base 8 of 48 equals log base 10 of 48 divided by log base 10 of 8. So let's go ahead and put those in our calculator. We're going to do the log button, log, of 48 divided by the log, log, of 8. We get 1.86. we can check our work. Well, actually, let's go back. That's as far as we needed to go. Log 48 over log 8d. Solving each exponential equation. But, by the way, if you do want to check your work, this is the number that you'll use to plug in for x. So we would have 62 plus 2 times 8 to the 1.86 should equal 14 plus 3 times 8 to the 1.86. So again, if you subtract, you'd have 48 equals 8 to the 1.86. We can try that out in our calculator. That's a pretty quick problem to check. So we will do 8 raised to the power 1.86. Pretty darn close to 48. All the rest is rounding error. So our next problems, solving each exponential and rounding to the nearest 100th. So first thing we're going to do is we're going to isolate our exponential. So we're going to divide both sides by 7. So e to the 2x equals 2. The next thing we can do is take a natural log of both sides. So we know that e to the 2x, when we take the natural log of that, we get the exponent 2x. And that's going to equal the ln of 2. So to get x by itself, we're going to divide each side by 2. So x equals ln of 2 divided by 2. ln of 2 divided by 2, we'll throw that in the calculator. Natural log of 2 divided by 2. 0.35, we're going to round up. So remember that was 0.346, so we round up. E to the 3x plus 1 equals 8. Subtract 1 from each side. E to the 3x equals 7. Now we're going to take the natural log of both sides. So 3x equals the natural log of 7. Divide each side by 3. So x equals, let's pull up the natural log of 7, ln of 7, and we're going to divide that by 3. 0.648. Going to go to the nearest 100th, so that is 0.65. And if you like using the little approximation, that's fine since we are rounding. Next, 3e to the 3x plus 1 minus 2 equals 10. We're going to isolate our log, add 2 to both sides. 3 times e to the 3x minus 1 equals 12. Divide both sides by 3. E to the 3x minus 1 equals 4. Take the ln of each side. 3x minus 1 equals the ln of 4. We're going to add 1 to each side, and we're going to divide by 3. So in our calculator, we're going to have the ln of 4. To that, we're going to add 1. We're going to take that sum, and we're going to divide it by 3. By the way, I would have had to use parentheses around that before I divided by 3. Otherwise, it would just add 1/3. That's why I hit enter first. So 0. Oh, I made an error. This is 3x plus 1. Let me fix that. So this is going to be minus 1. Clear. ln of 4 minus 1. 3.386, and then we're going to divide that by 3. 0.128, or approximately 0.13. Number 4. 3 to the x over 5 minus 5 equals 11.3. Again, we're going to isolate our exponential term. So we're going to add 5 to each side. 3 to the x over 5 equals 16.3. I'm going to take the log base 3 of each side. So I get x over 5 equals log base 3 of 16.3. Now I'm going to multiply each side by 5. X equals 5 log base 3 of 16.3. That is the exact answer. If we want to convert this, we need to go back up to our change of base formula, which we can do. So that will be 5 times log of 16.3, this is log base 10, over log 3. I'll leave that for you to do in your calculator. Problem number 5, you're going to subtract 9 from each side. 2 to the negative 2x equals negative 1. A positive number 2 raised to some power equals negative 1. How would that be possible? Even though it's a negative exponent, we know that that really just means 1 over 2 to the positive 2x equals negative 1. So we cannot have an output that is negative. So for this one, no solution. Oops. So next we're going to go over how to solve an exponential equation with two bases. So first, we're going to take the log, log, of each side. We're going to use the power property to bring down the power as a coefficient and then distribute. We're going to get the terms with an x onto one side, factor out our x, and then divide. This will make more sense as we do a few. So first, log, or log base 10, of 7 raised to the 2x plus 1 is equal to log, we're taking the log of both sides, step 1, of 3 raised to the 2x. So when we do this, we take our exponent out. So we have 2x plus 1 times log of 7 equals 2x times log of 3. Next, we're going to go ahead and distribute. So 2x times log 7 is 2x log 7. 1 times log 7 is plus 1 log 7, or just log 7, equals 2x times log 3. Next, we're going to get the terms with an x on one side. So to do this, I'm going to move my 2x log 3. We're going to subtract that from each side. And we're going to subtract log 7 from each side to get everything with an x on one side, everything without on the other. So I have 2x, I'm going to change color just to make this a little easier. I have 2x log 7 minus 2x log 3 equals negative log 7. Now I'm going to factor out my x term. So x times 2 log 7 minus 2 log 3 equals negative log 7. And then I'm going to divide. So I'm going to divide both sides by 2 log 7 minus 2 log 3. So let's solve that. So these cancel, and this is our value for x. Calculator. Negative log 7 divided by the sum of 2 log 7 minus 2 log 3. Negative 1.148. We'll call that approximately negative 1.15. And in our next example, number 7, we have 5 raised to the 3x minus 1 equals 8 raised to the 2x plus 1. Once again, we're going to take the log of both sides. When we do that, we use the power property to bring down the power as a coefficient. So 3x minus 1 times log of 5 equals 2x plus 1 times log of 8. Now we're going to distribute 3x log 5 minus log 5 equals 2x log 8 plus log 8. I'm not going to write out the subtraction, but I'm going to go ahead and move my x terms to one side and my non-x terms to the other. So I get 3x log 5 minus 2x log 8 equals log 8 plus log 5. I'm going to factor out my x. X times 3 log 5 minus 2 log 8 equals log 8 plus log 5. I'm going to divide by this term. 3 log 5 minus 2 log 8. So those cancel out. I'm left with x equals, work for the calculator. So, on the top, parentheses, log 8 plus log 5. Close my parentheses, divided by parentheses, 3 log 5 minus 2 log 8. Hopefully I have enough parentheses here. Oop, I forgot a parenthesis. Oh, no, I didn't. Good to go. Got to make sure they all match up, or you're going to get a wrong answer. So I get 5.510472, blah, 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 5.51. I'm going to go ahead and write a couple extra significant digits, because I'm going to go back and check my work. So I'm going to go 5 raised to the 3 times that, and see if that's equal, plus 1, see if that is equal to 8 raised to the 2 times that, plus 1. So 5 raised to the parentheses 3 times 5.51047 plus 1. That's a big number. 8 raised to the 2, go back, parentheses, 2 times 5.51047 plus, I did the other one wrong, didn't I? 1. I had to subtract 1 from the other one, that's why they're not matching. So again, 5 raised to the 3 times 5.51047 minus 1. Now I get the same answer, 7.177 times 10 to the 10th. So that worked. Vocabulary. To solve an exponential equation in quadratic form, use factoring. When I say factoring, e to the 2x means e to the x squared minus 2e to the x minus 3 equals 0. So think about that like x. So I have x squared minus 2x minus 3. So I'm going to use, if you want to call it factoring, with u substitution. Where in this case u equals e to the x. So u squared minus 2u plus 3 equals, minus 3 equals 0. So what do we get? We get u minus 3 times u plus 1 equals 0. So either u equals 3 or u equals negative 1. What was our u again? Right there. So either e to the x equals 3. We'll take the ln of each side. X equals ln of 3. Or ln e to the x equals ln of negative 1. ln of negative 1. Let's see what that is. ln negative 1. There isn't one. It's a non-real answer. Let's take a look at the ln of 3, though. 1.098. So 1.10 approximately is what x equals. We do the same thing with the next one. This is really 2 to the x squared plus 2 to the x minus 12. So we'll let u equal 2 to the x. So u squared plus u minus 12 equals 0. So u plus 4 times u minus 3 equals 0. So either u equals negative 4, well, we know that that's not going to work, or u equals positive 3. So log base 2 of 3 is going to equal log base 2 of 2 to the x, which is x. So how do we get log base 2 of 3? Once again, using change of base. We know this is log of 3 divided by log of 2, which is approximately 1.58. Hope you enjoyed day 7 video.